September 1944. Arracourt, France. A fog so thick you could not see 30 feet. Lieutenant Edwin Leiper of the 704th Tank Destroyer Battalion spotted something in the gray, the muzzle of a German tank. A Panther, 45 tons of the most feared armor in the Wehrmacht. Leiper commanded a vehicle that weighed less than half that, a machine with armor so thin that 30 caliber rifle bullets could punch through the turret sides at 75 yards, a vehicle that every conventional military thinker said was a death trap. In the next 5 minutes, his platoon destroyed 5 Panthers. They lost 1 M18 Hellcat. Over the next 3 days, the 704th knocked out 39 German tanks. They lost 4. Hellcats destroyed. 3 damaged. By the end of World War II, the M18 Hellcat had achieved the highest kill-to-loss ratio of any American tank or tank destroyer, 526 confirmed kills, a ratio of 2.4 to 1. The vehicle everyone said would fail became the most effective tank killer the United States ever fielded. This is the story of how American engineers built a tank destroyer that defied every rule of armored warfare, and how American crews proved them right. When Germany invaded Poland in September 1939, military observers watched in horror as panzer divisions punched through defensive lines that had held for weeks in the First World War. The Blitzkrieg changed everything. Static anti-tank guns could not reposition fast enough. By the time defenders identified the breakthrough, the panzers were already behind them. The United States Army drew a conclusion that would shape American armored doctrine for the entire war. They needed a mobile reserve force, tank destroyers, vehicles fast enough to rush to any breakthrough and destroy enemy armor before it could exploit the gap. In 1941, Lieutenant Colonel Andrew Davis Bruce took command of the newly formed Tank Destroyer Force. Bruce had a vision. He wanted something faster than a tank, better armed, a cruiser, not a battleship. He understood that in armored warfare, the first shot often decided the engagement. Speed meant reaching the right position before the enemy expected you. The problem was that nobody had built such a vehicle. The M10 Wolverine, America's first purpose-built tank destroyer, mounted a 3-inch gun on a modified Sherman chassis. It weighed 30 tons and topped out at 30 miles per hour. Bruce objected. Too heavy. Too slow. When the M36 appeared with a 90mm gun, Bruce objected again. It was just an M10 with a bigger turret. The Ordnance Department tried everything. They mounted a 37mm gun on a light tank chassis. Too weak. They tried a 57mm. Still inadequate. They attempted a 75mm on an M3 light tank frame. The combination was unstable and underpowered. Bruce wanted something that did not exist. A vehicle light enough to reach 55 miles per hour, armed with a gun capable of killing any German tank, and simple enough to mass produce. The engineering challenge seemed impossible. The solution came from an unlikely source. Not the Army Ordnance Department. Not a military contractor. A car company. Harley Earl ran the design studio at Buick, a division of General Motors. His team had designed automobiles, not weapons. But in December 1941, when the Ordnance Department issued specifications for a fast tank destroyer, Buick's engineers saw a challenge they understood. Weight reduction. Power-to-weight ratio. The same problems they solved every time they designed a new car. They started with the engine. The Continental R975, a 9-cylinder radial, originally designed for aircraft. The same power plant used in the Sherman tank. But where the Sherman weighed 33 tons, Buick's engineers designed a hull that weighed less than 20. The first key innovation was the torsion bar suspension. Previous American designs used volute spring systems that added weight and limited speed. Buick's torsion bars provided a stable ride at high speeds while cutting hundreds of pounds from the chassis. The engineers tested their prototypes on the same oval track they used for passenger cars, pushing the vehicles until components failed, then redesigning. The second innovation was the Torque-matic automatic transmission. Most tanks of the era used manual gearboxes that required driver skill and slowed acceleration. The 900T Torque-matic allowed the Hellcat driver to focus on maneuvering while the transmission handled gear changes automatically. In combat, this translated to faster response times and smoother handling at high speeds. The trade-off was armor. The Hellcat carried just 13 millimeters of steel on the frontal hull, 25 millimeters on the turret front, less protection than an M8 armored car. In testing at Aberdeen Proving Ground, evaluators fired 30 caliber armor-piercing rounds at the turret from 75 yards. 9 out of 30 penetrated. Critics called it a death trap, but Buick's engineers understood something the critics missed. The best armor is not being where the enemy shoots. Speed was protection. If the Hellcat could flank enemy tanks, fire into their vulnerable sides, and relocate before they could respond, thin armor became irrelevant. The production M18 weighed 17,700 kilograms, approximately 19.5 tons. Length was 6.68 meters with the gun forward. Width was 2.87 meters. Height was 2.57 meters, lower than a Sherman by over 30 centimeters. The Continental R975C4 engine produced 400 horsepower at 2,400 RPM. This gave the Hellcat a power-to-weight ratio of approximately 23 horsepower per ton, compared to 15.4 for the Sherman and 13 for the German Panther. Top speed on roads reached 55 miles per hour, 89 kilometers per hour. Some test vehicles on banked tracks achieved 74 miles per hour, with special tracks fitted. Off-road, the Hellcat could sustain 28 to 31 miles per hour. No other tracked armored vehicle in any army matched these speeds. The main armament was the 76mm M1A1 gun, the same weapon fitted to late-model Shermans. Muzzle velocity was 792 meters per second with standard armor-piercing ammunition. The gun could penetrate 109 millimeters of armor at 1,000 yards with APC rounds. The Hellcat carried 45 rounds. Secondary armament consisted of one Browning M2H B50 caliber machine gun mounted on the turret ring with 800 rounds. The open-top turret design gave the commander excellent visibility but left the crew exposed to artillery airbursts and infantry attack. The crew numbered 5. Commander, gunner, and loader in the turret. Driver, an assistant driver in the hull. The engine was mounted on steel rollers that allowed maintenance crews to disconnect it from the transmission and roll it out onto the lowered rear cover in minutes. This simplified field repairs dramatically compared to other armored vehicles. Production began in July 1943 at Buick's Flint, Michigan facility. The initial contract called for 1,000 units. When Buick completed these by January 1944, the Army ordered 1,800 more. By the time production ended in October 1944, 2005, 107 M18s had rolled off the assembly line. Peak production reached 250 units per month. If you're finding this deep dive into American engineering useful, consider subscribing. It helps the channel and ensures you don't miss the next one. The M18's combat debut came in May 1944 at Anzio, Italy. 5 T-70 prototypes, the pre-production designation, were deployed with the 894th Tank Destroyer Battalion for evaluation under fire. The results were mixed. Crews praised the speed and the ability to get into firing, position faster than any vehicle they had operated, but the thin armor concerned commanders. The T-70s saw action during the breakout from the Anzio beachhead, though their role remained limited as evaluators collected data on mechanical reliability and crew feedback. The 894th had been trained on M10 Wolverines. Many questioned whether trading the M10's thicker armor for the Hellcat's speed was wise. The question would be answered in France. By summer 1944, 3 tank destroyer battalions equipped with production M18s had landed in Normandy. The 40th, 603rd, 704th, and 705th were attached to General George S. Patton's Third Army. Their moment came in September. Hitler ordered a counteroffensive to stop Patton's advance toward Germany. The 113th Panzer Brigade, equipped with Panther tanks, struck the Sassons, 4th Armored Division near Arracourt on September 19, 1944. The 704th Tank Destroyer Battalion was attached to the division. Dense fog blanketed the battlefield. Visibility dropped to 30 feet or less. Under these conditions, the Panther's advantage, its devastating long-range gun that could kill Shermans at 2,000 meters, evaporated. Combat would happen at close range where the Hellcat's speed and the crew's training could make the difference. Lieutenant Edwin Leiper led a platoon of Company C to a hill near Rechicourt-la-Petite. When he spotted the muzzle of a German tank emerging from the fog at 30 feet, he deployed his 4 Hellcats. In 5 minutes, 5 German tanks burned. 1 M18 was lost. The platoon continued fighting. Sergeant